The elevator bell crank is a critical mechanical component that connects the actuation from the pilot's joystick directly to the elevators that control pitch, and you can see the original design here. But instead of using a designer's imagination for the redesign, they decide to use topology optimization to suggest a new potential design. To do this, the designer first starts with a model of the design space, meaning the area that the crank could fit within. In this case, the gray area is the design space, and only half of the design space was modeled since it's a symmetric part. The red area represents an area where we don't want the material to be placed for the design. The designer picks the topology optimization solution from the NX interface and follows the simple commands in the menu that are laid out in the steps of the process. The designer first identifies the design space, symmetry plane, and material for the design space. The designer also notes that there are pin connections within the design space, which the optimizer will then maintain as it determines the part shape. The designer also identifies the red areas as the keep-out zones. Next, the designer defines loads that the part will experience at the pin connections. The final step before running the solution is to set up the optimization targets, which is set to 0.17 kilograms for this part. The topology optimization run is then submitted, and it takes some time for it to run through all of the iterations, which we've edited out here in this demo in the interest of time. Once the optimization is complete, the results of the new shape are created in the form of facet data, which we can then open in NX. You can see the new part here in blue. If we isolate the part and its design space, you can get a better feel for the new part shape and how it's radically different from the original shape. Traditional CAD tools can't do precise design operations on facet models like this one. You would actually need to completely remodel this part in CAD using the facet model as a guide in order to get usable geometry that you can then refine.